A very good evening, my friends. My name is Rojkumar Gadhwal. So, as per my last presentation, some topic we have discussed about generator protection, and there is some query regarding generator protection, and someone want to some specific portions about the protection. So, I try to add these topics in my slides. So, one by one, we discuss about this. I think all of are in protection system, and I'm very welcome to you, and I hope there is a bilateral process. Otherwise, first of all, this is only an introduction session, and the whole class to be discussed further. So this will be the good for us. And my opinion is this: everyone who have the knowledge, their experience, so during the classes we will get interacted and we will discuss one by one, and we will share their opinion, some experience also. So this is a bilateral process. So first of all, just we begin with this. Okay, so everyone know about the basic things about the generator. So, but we'll just some interesting thing I just want to add here. So, this is our generator as per our drawing. This is a prime mover. This is further connected to our turbine, which is rotated through steam. If the thermal power plant of the other mechanical inputs, it may be the gas turbine also. There's a field excitation. You know the field excitation because some we have the two parts in generator. There's a stator and rotor, and you know the rotor is rotating path and which create the rotating magnetic field, and stator through stator is connected to our duct and bus ducts, and this bus duct directly flow the current to our outgoing system like switchyard or our substations. Okay, similar things. What is excitation? You know, so here this is a generator. This is a generator field. You can see this is generator field. This is generator. Here this is our DC breaker. You know, DC breaker. This is a automatic voltage regulator. This is a static exciter, and this is a CT and VT. So we know. So one by one we'll discuss about this how this function is work. So suppose there is some certain frequency had dropped in the system, so in this time our voltage, our system will get some disturbance, and this disturbance to overcome through this AVR system. This AVR system which allow us, and through the AVR system we can improve our excitation voltage, so accordingly their flux will be more, their flux will create the voltage, and this voltage will directly match with our grid system. So this is the basic introduction, and the detailed working principles and detail how it's work, and what is the range, how was the system, what was the value, and what is the basic requirements we will discuss. Okay, so this is the basic diagram. Whatever the CT and VT, this is directly connected to a duct. This is our generator, so we can get the input from this CT and this VT. AVR, this AVR is giving the also for the excitation transformer. This all the inputs we are get this is our AVR system. This AVR system again feedback to converted to DC system, and DC voltage is feedback to our generator. This is our field extraction system. Okay, now next slide we can check. So in in rotor, this is two type of rotor. When this is a cylindrical rotor and silent rotor. What is the difference between a cylindrical and silent rotor? So cylindrical means this you can also check here. This is the stator, and this part is a rotor. So there is a number of teeth, na? You can, there is a number of teeth. This means this is the windings. You know, this is the windings. Or this is the this is the stator in the silent pole. This is the stator. This is only saying only two poles. Okay, so according to our frequency, we can check here that what were our frequency. So our frequency in India, there is a frequency in 50 hertz. So according to our system, you can see here this is 120 f by p. So what is a 120 by f by p? So 120 f by p means suppose our generator is running is 3000 rpm. Okay, just a minute, just a minute, just a minute. ठीक है. Our generator is running 3000 rpm. In this case, we can check 3000 rpm is 120 f by p. What is the speed? 3000 rpm. What will the frequency? That will related to our pole, 120 f by p. F is frequency divided by p. That will be our 50 hertz. This silent power, our stator is using in our hydropower plant basically, and for cylindrical rotor in will be used in our thermal or steam power plants. Now, this is our cylindrical rotor and stator. You can say this is the layout of thermal power plant. In thermal power plant, this is the stator. This is a process is inserting the rotor in the stator. So this is a rotor, and this is the rear side of the generator is the steam. It's a turbine, turbo generator. So you can check here. Very carefully we are inserting our rotor to stator. So this is like this. And one more things, this is a hydro generator. There is because there is sometime Kalpan turbine or some other turbines we are using. So this is directly fitted on this top of the generator. Now, uh, this slide is very important because suppose our system is running smoothly. In these conditions there is a fault in the system. It may be the outside of generator or the inside of generator. So be just listen carefully. Suppose this the part of this, you know, this is our graph. You can say it's decaying with respect to time. And just look at here. This is our generator and this is our breaker system. And this the cross section is our this is our breaker. In this time, what will happen if the current is flowing towards our system? Our power will flow like this, na, generator current, and this is a fault. So both the current from the system, which is directly connected to grid, and current from our system means our generating station will feed the current to the faulty section. So the heavier current will flow at the point of the at the fault points. Okay. Now, suppose at the time of the running condition, our current is very suppose before the fault, or the you can say just before the fault, current is high. Okay, and as the system current is high, as the fault is occur during the time before the generator breaker trips, the current will be decay because there is a fault, no? Because fault means the current is flowing towards the fault conditions, and this will very interesting things. The current decay is the current. This is a generator current decay because fault is going, the current is going toward the fault. Okay, so generator after the breaker will trip, na, a generation will be lost, and that time the current what is the quantity of the current generating quantity ampere, it is trying to decay. So this is very important. The fault conditions, what will they happen in our system? Now, there is three type of the fault conditions. You can check here. This is a transient period, and steady state period. So what will be happen? Suppose this is short circuit current at the zero stand. There is time period is very less. Okay, is very less. In this 1 to 2 seconds. So there the disturbance is very high. You can check here. The frequency, the curve is exponential tangent. You can check here. This is decay as the time will be more, na, this is going to sustain. It's because the fault the sub tangent condition, because this is very certain friction of time the fault will occur. This time the fluctuation of the current is very high, and as the time will decay, the system going to smooth. The same time our system, the fault current which is very fluctuating in initial condition, which always trying to get a steady state conditions. Okay, so these are the conditions, and we can also check. So what will be actually happen when the system what will actually physically happening in our system at the time of the fault. Okay, so you can check. One more thing I also want to add here, there is not only for the AC current will be the part will affect our system, but some part of the DC, so which is also affect our, you can check here the current phase A, phase B, phase C. These in phase C conditions, they are as similar as AC component, AC current, but here there is some differences between the, you can check, DC current is not as similar to as graph C. You can say the so some part is in AC phase AC current is shifted to earth, in DC phase AC current is shifted to earth. So it is also the you can check this is also the impacting the our DC component. So in this when the system is designing, so we can also consider our the fault conditions. You can say DC component we also AC square plus DC under root by DC square by 4. We can check the component of these two conditions, because your breaker, your generator breaker or GCB should be capable of the withstand these two components, because not only DC is impacting our system, the some not only AC is impacting our system, but DC is also measuring the same pole. The fault conditions, the fault table should be withstand. Okay, so this is because some transient conditions we can use this type of component fault. So further we can explain about this. Okay, now grounding techniques. So why grounding techniques we added here? ठीक है. So one thing is some parts is very interesting, so we can use Hindi language also. There's no issue. Some parts. So why grounding system is required? System is okay, our system is running, so you can check here fault equipment detection, because the root of the returning current is also required. Transient over voltage. Okay, how it work will be discussed in our slides which is coming. And ground fault before the multiplier phase, so it will suppose the ground fault, so in case it will return current will be required, as I told you. Okay, limiting ground current fault, suppose there is some unbalanced current also going to fault through neutral, so it is also the limiting for the ground. So this is also useful for the ground source for the system. Okay, type of grounding. So you can check here, this is our generator. Okay, this is our generator. Okay, this is our grounding resistance and this is our directly connected. So R by B is going to upward direction. Okay, or in this case R by B, this is your neutral side. Okay, so good ground is the resistor is a low, very low resistance we will use for better grounding system. Low resistance for damage to ground. So in these conditions it is a low resistance, means the it will limit the certain amount of the current which is unbalancing current, so it is not allowed to ground the system. So in this case our system will be the stable conditions. Okay. So ground fault capacity should be 4000 ampere, 400 mA, sorry, 400 ampere. Okay. So as I have written, the good ground source resistance, so lower better ground source, the lower resistance, the more damage to the generator on the internal ground fault. Can excessive as a resistor voltage rating goes up, generator will be damaged on the internal ground front. What is the demerits? Also some demerits mentioned here. So in this case we have NGR, we are using that transformer. So the primary side of the generator is directly connected to our neutral, and secondary side of the generator is connected to NGR resistance, which is not directly connected to resistance, but secondary will be connected to resistance. So here this value is also very important. Okay, the high impedance is called high impedance. So it is a with delta YY generator stepped up create unit connection. We can, you know, the pew units of the system. We suppose there is a fault analysis, we are not only considering their impedance, but we are converting all the faulty, all the electrical system in the common unit which is called the pew per unit impedance. Okay, so that is our basic calculation process. So we can also discuss about this system ground source obtained from the generator step up transformer. Use the principle of the reflection. So NGR means the resistance of the primary voltage, secondary voltage square root, so we can get the NGR value. Okay, now uh, of, one more thing is type of generator grounding. Okay, in type of generator grounding there is a hybrid impedance. In hybrid impedance, the both the section there is some, you can check here, this is a neutral side and this is a neutral side. Sorry. Okay, this is our neutral side. Just one more thing I just wanted. Okay, This is neutral side and a VS source, R source. Okay. So and accordingly we can use our protection relay also. This is our 100% shutter fault. We can use this system. So what is a 50N protection? We can discuss about this. So this is a 86 differential. We can say this is a differential between a neutral and primary voltage. So 86 differential we can check here. So what are the actual number of benefits of this 87 GD, why low resistance ground path using, what is that generator grounding. So again we can discuss about this. Okay, now data groundings, both the systems, same thing we have discussed. Fault type of the generator, ground faults. So what are the ground faults, what is the impedance, why this value is 100 ampere, why what is the kind of values. So and one more thing I just want to mention here, the stator ground fault damage. So suppose there is a fault in the system, in this system which is the heavy fault current will be damage our system insulator. This is some picture I have added here, so you can check. This is a faulty part, this is stator, and there is some blackish, this is a carbon typically damage. This is you can check here, this is very dangerous for any system, because if your generator is the heart of the plant, if your generator will damage, there is no any power generation, so it will be the very expensive, not an expensive, but the generation will be lost na. So it is very important for IT engineer to protect your generator in any cost. Your protection switch system should be very healthy. Your relay should be very coordinated. Your time to time maintenance is very important. So all the responsibility of engineer is very important if you are working a generator. So why the generator protection people is very demanding and very important for us. You can check here also. Okay,
Okay,
friend.
friend,
Good
good
morning.
morning.
So